All right, back with part 3 of the Plywood Fish Aquarium 200-gallon build. It's a little brighter in here today because I finally got the light system up and running on the aquarium here and have it all finished, and it's all waterproof. And actually it is waterproof testing time. That's the whole reason why we're doing this video, to catch you all up on how I have got this far. So to give you guys a look here, this is the inside. Like we had said before in a previous video, we went with this style plumbing reservoir here, overflow. We're gonna see how this holds up. We got the Fluval smart lights operated with the app on the phone. Color changing lights. Right now I just have them set to just white. So I spent the last couple of days doing the filtration system. It's a multi filtration system. It's canister filter, fluidized, and hopefully, depending on the water test that we do with how the system works with the overflow here, it could be a dual fluidized system, or it could be a one side fluidized and the other side as a drip wet dry, I guess that's what you would say. So I'm gonna give you guys a look at what we have so far. All right, so this is pretty cold out, so hopefully all this holds up and don't freeze. It's been pretty cold the last couple of days. 20 degrees and 15 degrees and 7 degrees one day, and it's just been a pretty crazy day. So right now what we're doing is balancing off the two like we did in the other video, and that I'm gonna show you right now. This is a quick video of, I'm doing the first, one of the parts of the filtration system in the 200-gallon plywood aquarium. What I'm trying to create is a fluidized system between two units, like a dual filtration system that's getting filtered by two canister filters. Like I said in the previous videos, what I'm trying to do is utilize some supplies that I already had on hand to aid me in this filtration system. So what you see here is two oval half moons tanks that I had purchased a while back, never got a chance to use. Also with two canister filters that I never got to use, that was brand new. So what I'm going to try to do is create a fluidized system. So I'm doing a water test. It's really cold outside. It's February 10th, so I'm not able to test this outside like I would usually do. It's kind of cold outside, so I just brought it in the house, and I'm just going to test it in the kitchen here. And I set it up and to get it running so I can monitor it and to see which one, to see if it balances off. That's really what I'm trying to see if the water will stay balanced between the two, or will one of them tip the scale more than the other one. You would think that since it's the identical of the two canister filters are the same, that they'll run equally, but usually that's not always the case. Sometimes one work more or less than the other one. And so that's what I'm doing to test here before I introduced it to the 200-gallon aquarium. So what I'm doing is I'm monitoring it like every 30 minutes or so with a tape measure. I have the tape measure, so I'm measuring this out just to see where the water level is on this tank and the water level is on this tank, like every 30 minutes. So I can see like how long will it take for the water to balance out or unbalance, and to see, just let time place, and also to test for leaks to see if my little fancy plumbing system here of combining the two to have them both work together at the same time, to see if they both balance each other off. So the test also test to see if it's any leaks on my plumbing. So I'll let you guys know. So this is the second test, the second check-in part of the video, where from the first video that I started at about 7 hours ago. So we like 7 hours in for as testing the system to see if the two canister filters keep balance of water between both tanks, which they have done that for us to test. They've been running pretty quietly and silently right now for the last couple of hours. So that particular part of the test is seemed to prove itself that it is stabilizing. So what I'm gonna also check for, which there was a small leak. I don't know if you can see that, just a little drip right there. So I'm gonna, at this time, I'm gonna shut it down and repair that and make some adjustments. I think I'm gonna put some valves on here and there just to have extra flexibility for its water pressure whenever I do start this up with the fluidized system. So I'm gonna shut it down for the night and I'm gonna start it back up in the morning. I don't want to run it overnight just in case something do go wrong. It'll be water all over the floor. So I'm gonna make some adjustments, the plumbing, shut it down, and then start it back up tomorrow. And we'll do our last test for this part of the system for the dual fluidized system. Okay, so since I drained one tank to see if it balance off, see if one tank balance off the other tank when one tank is drained, to see will it offset and level itself out, which it did, which is great. That's exactly what I wanted to do. So I drained one tank at 8 o'clock and it's now 9 o'clock. So it took about less than an hour because I came back a couple of times and checked it, and I saw that it was self-leveling itself out over, a course of like 10-20 minutes. It started to level itself out. It has the time frame factor does play a factor in it. It has its pros and cons, but it's the test. The end results of the test it's a good and a good. It's really not a bad. I would have liked to see it do a self-leveling faster, but over the course of time has its benefits as well, which means it won't overflow. And that's one of the main reasons of doing these tests is to prevent from overflowing, just in case if a power failure or something like that, or if one motor gives out and one motor stays on, it won't force all the water into one tank and it causes it to overflow. So that's the overall goal, is to do these series of tests, and just in case what if was to occur, what would happen real time. So I would cause a power failure to see what happens with the tanks, to see what they do, to see if they stay stable, or we'll see will it siphons back, or will it overflow, or what happens, or if one motor give out. Because the original plan was, because I still have two motors that I want to introduce to these two tanks. And before I introduce new elements or whatever to the tank, I must first know what each one does independently from the next. So I would do a test on the tanks with the canister filters and see how they work hand in hand, to see if they balance each other off and whatnot. And then before I introduce the other part of this system of functioning, I wanted to do a test to see what would happen if one motor was to give out versus both motors, or if one motor give out and what would the other motor do, stuff like that. So I would just have to make some small adjustments according to my data and my findings, and see what I have to do before I move on to the next part in the test. So overall, it did self-balance. So, and that was one of the things that I was looking for. So which that means I can move on to the next part of my testing. Check back. So with those first couple of tests done of creating the system and trying to get it to balance off and get it to work, I was successful. That I used to waterproof plywood aquarium, no leaks at all. So we was pretty successful getting it 100% waterproof, no leaks from the glass of any kind. Give you guys a glimpse. That is the flow of the water coming from the system at the bottom, and over here is the reservoir overflow weir system that I created to see if it would do what I plan on it doing. And so far, it has been working great. It's been doing exactly what I wanted to do. It's keeping the water level consistent where I need it to be. I think the water level is great. The flow that's coming out is good flow. Let's look at the top of this. Hopefully you guys can see this here. So that's the flow. Pretty nice flow. I think it has great water surface agitation. Looking pretty good. Looking at it from the top, it looks like it's a whole lot deeper than just looking at it from the front. Let's take a look at the other side here. All right, okay, so the flow is coming from that direction down here to the top weir that I created. Let me flip this door all the way so we can. So just like in the last video that we talked about, the water will flow through all of the outside holes that was drilled in the surrounding circumference of the pipe to make a decent amount of flow. And like this top part, like we discussed, with the top on, the sound is muffled of like when the water come crashing down into it, or the water is as it creates its vortex going down, the slurping noise that it makes going down. So it's doing exactly what I wanted to do. I wanted to act as its own weir plus, you know, overflow valve. So as just as much water that is being pumped into the main display, that is just as much water that will be coming out of the display, which is great. So that it will be no overflowing from the main display. No water will overflow from the main display. So like I was discussing in the last video of the silencing, so right now it's on and it's pretty quiet. What you hear is just the water coming from down from the bottom into the main display. But when you turn the top off, I don't know if you can hear, so it's a little louder. We can look down. So it's crashing down, it's making this vortex just like predicted, and it's making this, you know, loud water draining sound like it should. So with the top off, you know, that's what we hear. So when putting the top back on, and the sound is gone, just like that. So it's running. Give you guys another look at the system here. So this is the overall system that I created to work for this particular aquarium here. This side, which is my left, will be the fluidized system. Right now, and it's allowed right now because it has no media in it or nothing like that to help with the water. The water is just kind of splashing around, so it's kind of loud. The water comes out of the main display down, comes through here, flows over, and what's underneath here at the very top, it's like a H bar, T bar, allowing the water to stream down in as many different holes that I drilled inside of the bar that's connected to the lid of this particular tank. And what's supposed to be at this level right here is where the water will cascade over the sponges, the different layers of sponges, to mechanical cleaning. And then it'll get siphoned down. This is a acrylic sheet that I custom cut and drill a ton of holes in, allow the water to flow through down to the, like I say, if it's gonna be in this middle chamber here, and underneath here, like you have another acrylic sheet that's drilled with plenty of holes so water can easily flow through, and down to the return motor. That is easily accessible. If I need to switch it out, I can switch it out, which I plan on switching it out anyway, but I'm gonna let it be in here for a while. So in the middle chamber, this middle part here, we have the canister filter, and the canister filters is two of them. They both work together. They both filter both tanks and keep the balance of water in both tanks, and they'll do their job. If I'm gonna put ceramic rings or bio balls or the foam, carbon or whatnot, and different things like that in there, it'll help with the cleaning of the water. Like we discussed on this one, this side will be the fluidized system with the K1, so I have to order that, and the water level should stay consistent. I don't have it filled all the way up because, like I say, I'm still kind of testing it. So right now I just have a heater that I picked up today, a marine land here. So I will have to pick up another heater, more likely to have two heaters to heat the whole 200 gallons. So with this system, we have about 40 gallons of water in total on this side of water that's being filtered on top of the 200 gallons. So it's like the water value is like 240. So I will be getting another heater. So these airlines that I custom made plastic, I guess you can say flexible plastic tubes that I pre-drill holes in on both sides. They had the curvage already done from raveling them, so I just kind of kept it that way. Custom cut them and drill holes in and glue them down to this acrylic sheet. So that's a kind of a permanent fixture. So it'll help with rotation of the media as I put it, and it'll warm up down there. And then at the top right now, I just have the air pump just on top of it for right now. This is an update. Right now we're just doing some tests on to see how the water flow through the pipes, checking for leaks. No leaks. And then go on flow back to the main display. So in, out. Pretty simple. So you guys stay tuned for the next video. Hopefully we can maybe add some stuff in there. I'm pretty sure the fish that I plan on putting in here are gonna love it. Plenty space, plenty room for them guys to swim in. Hope the filtration system works great for them. It's not too loud. Pretty good system here. So you guys stay tuned. See you in the next video.